All right, welcome everyone. It is a pleasure to see everyone coming in. Um, Let me drop a quick message into our waiting room. I do apologize because I am trying to juggle, let's see, 1, 2, 3, 4 screens and 2 CPUs and 14 students currently. So this is normally a 2-person job, but anyway, without further ado, let me go ahead and introduce myself. My name is Lisa Blue. I am the Associate Director of the Center for STEM Excellence, and I am hosting these review sessions in partnership with the math department. By special request, I'm doing this one solo without a math partner. So hopefully we can get through this together this evening. I'm doing this specifically because the e-presence classes did not have the opportunity last time to ask questions. So for the format of the review, okay, I've got, let's see, oh, where'd my table of, oh, here we go. Helps if you remember where you put things. So I did go ahead and generate a table of contents. So this table of contents is just an introduction to what we're doing this evening. We have until 7:30, or if we still have questions, I can go a little bit longer, but not too much longer than that. So that you have access to this document, I'm going to drop it into the chat right now. So this is your copy of the document. It has been sent and should be available now. Oh, somebody can't hear me. All right. Can you hear me now? Okay. Can anyone hear me? Just a thumbs up, a yes. I want to make sure it's not my headset. Okay. Awesome. Thank you, Cameron. Appreciate it. Okay, Brianna, try turning up your volume to see if that helps. I've got everything maxed out here on my end, so hopefully, oh yeah, thumbs up. You guys are great with the emojis. All right, fantastic. All right, so I've still got some students coming in, so my presentation isn't going to be real smooth until I get everybody into the room. We are up to 17 students now. And so I'm going to keep dropping this document into the chat until everybody has a chance to download it. All right, so let me go ahead and drop that one more time. So if you're just joining us, there is a document that I am dropping into the chat. That is the document that I am using this evening to run our presentation. All right, so with the intro out of the way, all right, so I've got these student learning outcomes. Oh, and I should mention also that if you need to get in touch with me or you have questions, my name is Lisa Blue. My pronouns are she, her, and hers. All right, and my Apple Pencil says it's dying even though it's been charging all day. You can email me at lisa.blue@eku.edu and I can get you directed to the right person for assistance. All right, so what are these student learning outcomes? Student learning outcomes state what a student should be able to do after working through the material in a particular section. And so once you work through these student learning outcomes, I'm still admitting students, apologies. They're real helpful because, let me go ahead and just show you what one looks like. All right, so in chapter 3, we've got this quadratic, piecewise defined, and power functions are the topics. And we see that in the chapter 3 algebra toolbox, the algebra toolbox will not be topics that we go over together, but these do represent these foundational knowledge. And so if you're struggling with any of these foundational knowledge topics, this is something you should go back on your own time and make sure, there we go, make sure that you understand those topics. And so this could be talking to your CEC, talking to your course instructor, going to the Math Tutoring Center, going to the Student Support Center. Just make sure you get that help that you need. All right, so for example here, we've got this learning outcome and it says simplify expressions containing exponents. And so, yeah, my pen is going to insist on being dead tonight. If we want to look at that learning outcome and make it useful to us, we're going to say, how do I simplify expressions containing exponents? What does that look like? Are there particular steps to do that? All right. And so when we're doing that, we say, okay, do I recognize all the terms in this question? All right. Do I understand what the question is asking me to do? Can I find examples of questions that match this learning outcome? All right, so that's kind of like the background work. And once you have that background work out of the way, steps 1 through 3, then you say, okay, can I answer the question? And most importantly, do I know how to check my work? Can I solve for roots of a polynomial and then plug those roots back in to make sure that, yeah, that actually is the correct answer? So let me go ahead and drop this document into the chat one more time. I think everyone has joined us. All right, so the document that I'm looking at right now is dropped in the chat so that you can take a look at that. And then going back to our table of contents for tonight. So if this is a comprehensive final, then this will be all the material from chapters 1 and 2 that you covered previously, plus all of this information. So all of this information is just since midterm. Okay, and we will not go over the algebra toolbox information together. That's on your own, a CEC instructor, learning center, student support center type question. But I will entertain questions from sections 3.1 through 3.5, section 4.4, and section 6.1 through 6.3. These are the sections that are covered according to your Math 112A syllabus. All right, does everybody have a copy so they can look at this? All right. Without further ado, let's go ahead and hit section 3.1, which is on page 9. So I tried to model the behavior that I'm hoping you guys can demonstrate here. I'm going to stop my video because I'm going to spend the rest of this time squinting at my iPad. Okay. We've got one person who does not see the document. I'm dropping that in the chat. Make sure your chat is open. Okay. So once you have that document, if you can take a look at the document, we have several options here. Okay, so in section 3.1, we have the first learning outcome, describe characteristics of the graph of a quadratic function. We have graph quadratic functions in a given viewing window. We have write the equation of a quadratic function given a graph or points on the graph. So that's our third learning outcome. Our fourth learning outcome, find the coordinates of the vertex and graph quadratic functions. And then our fifth learning outcome, use the graph of a quadratic function to estimate the x-intercepts. The sixth one for that section, solve applications involving quadratic functions. And the seventh one, answer interactive figure questions involving increasing, decreasing functions. Let's see, 7, and then 8. Answer interactive figure questions involving quadratic function graphs. I think that is it for that section, yes. So look through those, and if you want to drop in the chat which questions you would like to see me work or answer questions over, that would be the best way for us to do this efficiently this evening. Now, there are 55 pages to this document, so we won't have time to do them all. But if you see a question that looks particularly gnarly or tough or challenging, let me know and I'll answer questions. If you also just want to unmute yourself, I can take questions that way. Okay, so I am dropping the document in the chat again. So make sure you can see that document. All right. All right, so if you go to the bottom of your Zoom screen and click on chat, that'll open up the chat and you should be able to see that document. Emily, do you see the document now? I can't see everyone on my screen. We have 23 students. Sarah, you can't either? Okay, there should be a file. Let me see. All right, I'm dropping this file into the chat. Okay. Alex and Sarah, do you have the, yeah, you do have the chat open. Okay. So you should be able to see that. Let's see. And I can't do it in a direct message. I'm sorry. Okay. All right, so let's go ahead and look at this. Do we have any questions on the first learning outcome in section 3.1? Let's see. Okay, I'm not seeing any questions. You can drop those in the chat or you can unmute yourself. How about in section 2 or 3? Do we have any questions over problems 7 through 12 or 15? Is the vertex where it crosses the y-axis? No, the vertex is actually, okay, if we look at question 15, we've got a vertex right there. And so question 15 shows us that the vertex is at the point h comma k. So right here, we've got the vertex, and we see that that does not cross the y-axis necessarily. The vertex represents either the maximum or the minimum of the graph. So in this case, because this parabola is opening up, this is going to be the minimum. All right, and so if we look at this little snippet I pulled from your textbook, the vertex is going to be at the point h comma k. So if we can get that equation in the form y equals, this a can be just a constant, and then x minus h quantity squared, a quadratic function, is always going to have x squared, and then plus k is going to be another constant. All right, how do you solve question 12? Okay, so question 12 is asking us to graph each quadratic function on a -10 by 10 by -10 by 10 plot. Okay, so it's asking us, all right, so if this is our x and our y, to go from -10 to 10 and -10 to 10. So this would be on your graphing calculator. And it asks, does this window give a complete graph? And so you would pick values for x and y. And so I don't have a graphing calculator handy. And so I would pick, well, is when x is equal to 0, what value does that give me for y? And I see y is equal to 0 squared minus 4 times 0 plus 5. All right. So that would be y equals 5. So my first point would be, let's go 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So this is going by 2s. All right, so if I'm at 0, 5, x is 0, y is 2, 4, 5. All right, I could just keep graphing it that way. And then once I have it graphed, I could say, all right, do I see enough of this to say, yes, I can see the shape of this quadratic function, or no, I cannot. And so you would do this on your graphing calculator. You could continue by just grabbing values for x. So I could also say y is equal to 1 squared minus 4 times 1 plus 5. So that gives me 1 minus 4 is -3 plus 5 gives me 2. So 1 comma 2. So 1, 2. All right. And so I do believe that this one would allow you to give a complete graph. So for 12, I would say, yes, this probably does work. All right. Does that answer your question, Sarah? All right. Fantastic. So whenever you guys are looking in the textbook, look for these purple boxes. All right. They've got some really good information, and I've tried to show you key pieces of information to pull out and write down in your notes so that you can model the studying behavior on your own. All right. So let's look at, let's see. So how about section 4? Do we have any questions there? This is where we are asked to give the coordinates of the vertex of the graph of each function and then graph the function on a window that includes the vertex. Okay, if we have questions, just bring me back to it. Questions 31 through 40 continue that process. Do we have any questions there? Okay, drop that document in the chat just in case. All right. All right, how about questions 41 through 46? Does anyone need to see those? Okay, I'm not seeing any requests for questions. I see someone just joined by phone. Because you're joining by phone, I'm going to just let you view this window, but if you email me afterwards, my email address is lisa.blue@eku.edu. I can send you this document so you can look at it later. Also, feel free to join us again tomorrow if you don't get your questions answered today. All right. And this is being recorded, so I will get this posted tomorrow as well. What about question 47 or 49, solving applications involving quadratic functions or answering interactive figure questions? Everybody comfortable with those? Okay, if I need to come back to that, just let me know. All right, how about questions 51 and 61? Okay, I have a hard time trying to figure out how to set up an equation from a word problem. I understand that. Let's go back and let's see. Let's look at this profit question, because there's a lot of profit questions in your textbook. So I'm guessing that's a pretty popular exam type question. So if we look at question 47, it's important to pull out what is needed to solve the problem and to define the variables. All right, so I would look at this and I would say, all right, here's an equation. So that's probably important. So I know P is equal to 32x minus 0.01x squared minus 1,000. All right, so that's the daily profit for a product. And it says X is the number of units produced. Okay, so X is units and P is going to be profit. All right, and so it says graph this function for X between 0 and 3,200. 0 and 3,200 are the number of units we're going to produce And then once we have that graph, we're going to say, what happens to the profit for this product when the number of units produced is between 1 and 1,600? And so given that we have this positive leading coefficient, oh, that one doesn't matter. If we look at, here we go. So the x squared term is what we need to keep our eye on here. So if I rewrite this, so I've got 0.01x squared plus 32x minus 1,000, as long as you always rewrite it so that it's in decreasing powers of x, that's going to help you make decisions. And so because we've got this negative coefficient here, this tells me that this guy's probably going to open down. And so this is not what it's going to look like, but this is just a rough approximation. And we're going to do this graph for between 0 and 3,200. So I'm guessing somewhere around here, we're going to get a maximum. And because these mathematicians are really clever when they write their questions, what's going on between 1 and 1,600? Well, I would say it's probably going to be increasing. All right, so this is just my gut instinct. And then what happens to the profit after 1,600 units are produced? Well, it's probably going to, we see this is increasing over here, so this will be decreasing. All right, does that help at all, Tabitha? I think the main thing is to make sure you're grabbing the equation and then writing out what do all of these variables mean. Okay, and we've got plenty of word problems to look at here. Oh, when you're not given the equation, okay, understandably. Let's see. I will keep that in mind. Okay, so 73. All right, so question 73, apartment rental. The owner of an apartment building can rent all 100 apartments if he charges $1,200 per apartment per month. Okay, so maybe we could say that there's 100 apartments. So I pick out the key information. There's 100 apartments, and when we have 100 apartments, that gives me, that yields, this is my chemist showing here, 1,200 per month. Okay, so that's going to give me the maximum profit because he's renting all, but that's only true whenever it's 1,200 per month. Okay. But the number of apartments rented is reduced by 2 for every $40 increase in the monthly rent. Okay, and so this is where constructing that table will help because we can look for the patterns. What are the patterns here that will help us figure out the best way to write this? And so when we do this, if we consider that, okay, let's make our table. So if we've got the rent and we've got the number of apartments and we've got the revenue, that's going to be the 3 key factors. And so we know when the rent is $1,200, he rents all 100 apartments, and the revenue, okay, so the revenue is going to be the number of apartments times the rent. All right, so 1,200 times 100 apartments gives us a revenue of, let's see, 120,000. I'm getting my, all right. And then if we follow the pattern, so it says rented is reduced by 2 for every $40 increase. So our next rent will be 1,200 plus 40. Whenever we have 1,200 plus 40, the number of apartments decreases by 2. And so now we've got 1,240 times 98. Drop that into a calculator. That's going to give us a revenue of 121 520. And so you could keep doing this. You could keep adding $40, keep reducing the number of apartments. Okay. And as you do this, you can graph this in your calculator, and that calculator will give you an approximation. It'll give you a formula, and you can tell it, hey, I need a quadratic formula to describe this, and that will help you come up with the appropriate formula. So the next piece in this is it says, does the revenue equal 1,200 plus 40 times X times 100 minus 2X? Model the revenue from these apartments if X represents the number of $40 increases. Let's see, so X equals the number of $40 increases. So the thing to do would be to say, okay, when X equals 1, does that X equal 1, does that model my first increase? And so you plug in the numbers to see if it does. All right, does that help you figure out how to work through that problem? A lot of times you wind up plugging in data points, graphing it on your calculator, and then saying, okay, does their graph help? Does it model the data? Okay, so that's section 3.1. We have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 more sections to cover and an hour left. So section 3.2, do we have any questions over problems 1 through 11? Solve quadratic equations using factoring. I do have a note here to see the handout on the AC method. If you don't have this AC method handy, I recommend that you go to the Math Tutoring Center. That is in Wallace, and it's on the 3rd floor. And they have these handouts available. They also have them on their website. All right, so the AC method, very helpful. All right, how about any of these questions? All right, so let me see here. We have question, let's see, 12 through 16 as one set of information. So 12 through 16, find the x-intercepts algebraically. If we are looking at questions 17 through 22, we want to solve quadratic equations and find x-intercepts graphically. Any questions on those? Questions 29 through 34, we're using the square root method. And questions 35 through 38, we're solving quadratic equations by completing the square. Do we have any requests to see any of those on this page? Square root question, please. Okay, the square root, how to solve 29. Okay, I like it. So let's look at number 29. I'll place it right here. So the square root method tells us that when x squared equals some constant, that we can take the square root of both sides and solve for the answer. So we have 4x squared minus 9 equals 0. So we want to get it in this format, like the snippet I pulled from your textbook. So to do that, we're going to start isolating x. So we're going to say 4x squared minus 9 is going to become 4x squared. We're going to add 9 to both sides. And then we still want to keep isolating x so that we can say x squared is equal to a constant. So we're going to divide both sides by 4. we get x squared is equal to 9/4. And then we're going to take the square root of both sides. When we do that, we get x is equal to 3/2. But then we have to recognize that, well, we could have gotten that from saying 3/2 times 3/2 equals x squared. But we also could have said -3/2 times -3/2 equals 9/4. Okay, so we need to say x is equal to plus or minus 3/2. Does that help with question 29? And do we need to see another? Helpful, wonderful, fantastic. And it's the same process even when you get down into the scary ones like 34. Okay, so complete the square to solve quadratic equations. Question 35, great question. Okay, so when we're completing the square, we are going to say x squared minus 4x minus 9 equals 0. Here, I'm looking at too many things. There we go. All right, and so to complete the square, we're going to say x squared minus 4x. And then I'm going to go ahead and move this 9 over to the other side. And I've got a request for 38. I'll add that next. So I'm going to add 9 to both sides. And now I've got this x squared minus 4x. If we take that 4x off to the side, okay, we're only really worried about the coefficient. So we're going to take 4, divide it by 2, and we get 2. And then we're going to square it. So that tells us we need to add 4. Okay, so how does that work? When we add 4, if we do it to the left-hand side, we have to do it to the right-hand side. And we're adding 4 because we see that when we say x minus 2 times x minus 2, okay, that's going to give us equal to 13. We see this 2 showing up here. And the only way we could get that 2 showing up here was to add 4 to both sides. Okay. And so we get x minus 2 quantity squared equals 13. We take the square root of both sides, and I'm going to scoot this up just a little bit. And so we get x minus 2 is equal to, and again, we could have used positive x minus 2 or negative x minus 2. And so we're going to say this is equal to plus or minus the square root of 13. And we're going to leave it kind of gnarly looking like that. And then we're going to get rid of these parentheses because now we're going to add 2 to both sides. So x becomes 2 plus or minus the square root of 13. All right. Does that make sense? Pull that up so you can see it. All right, so if we look at 38, 38 is going to be a similar process. It is complicated a little bit by the fact that we have this leading to coefficient, but you go through the same process. All right, so 38, and I want to keep an eye on our time here. 2x squared minus 9x plus 8 equals 0. So let's see. It would be easiest if we divided everything by 2. So I'm not going to go out into the weeds on this one. Just suffice it to say, we would say 2x squared minus 9/2 x. And then we're going to add something in there to complete that square. And then I would pull this -8 over here. So I would take this piece and work with this piece. Uh-oh, come on, pen. I would take the 2x squared minus 9x and work with that, and then just pull the 8 over to the other side as a -8 to work through that. All right, so let's go ahead and take a look at the next learning outcome. How does everyone feel about using the quadratic equation? Are we comfortable with that? Okay, and then solve quadratic equations having complex solutions. Complex solutions means that we're going to wind up with I being in the solution. So like 49, x squared plus 25 equals 0. X squared is going to be equal to negative 25. And when we take the square root of both sides, there's going to wind up being an I. Okay. How about the next learning outcome? Use the discriminant to determine the number of solutions of a quadratic equation. And I included this little snippet from your textbook. The discriminant, keep in mind, is the b squared minus 4ac in the quadratic equation. All right, so this is just another tool to keep in your toolbox as a method for checking if there's two real solutions, one real solution, or no real solution. All right, and if there are things I am saying that you guys have not covered in class, feel free to disregard or to tell me to move on. I'm totally fine with that. All right, solve applications involving quadratic equations. All right, our lovely word problems. So with these, it looks like most of these do give us an equation. We just need to make sure to go through and define the variables. Once the variables are defined, then we can plug in zeros or factor or solve as requested. If you guys look at this packet later and still have questions, feel free to take that to the Math Tutoring Center, the Student Success Center, to your CEC or your instructor and ask them for help. These are questions directly out of your textbook, and the odd numbered questions will have the answers in the back of the textbook. All right. Moving on to section 3.3, we've got 1, 2, 3, 4, 5, 6, 7 sections left to cover in a little less than an hour. Identify power functions. All right, so power functions are going to be those functions with the form y equals ax to the b, where a and b are real numbers and b is not equal to 0. All right, questions there? All right. Graph power functions, questions 15 through 18. Solve equations involving integer exponents, questions 19 through 22. Any questions there? All right. Solve equations involving rational exponents. Any questions there on 23 through 30? All right, the next learning outcome, solve direct variation problems involving power functions. A direct variation means that as one variable changes, the other one varies along with it. And in this case, direct variation is going to be raised to a power. Solve applications involving power functions. Does anybody want to see 37? Okay, if you do, and I've gone past it, feel free to tell me to go back. I have no problem with that. How about questions 43 and 45? Answer interactive figure questions involving power function graphs or radical function graphs. Okay, if you want me to go back, let me know. How do we feel about piecewise defined functions? Okay, so in section 3.4, we start off evaluating piecewise defined functions. And then we graph piecewise defined functions. Let's see. All right, is everybody still with me? Zoom just locked up on me. Okay, fantastic. Zoom is weird. Okay. How about graphing piecewise defined functions? Are we good with that? Okay, you're going to have to drop it in the chat. All right. How about absolute value equations? When we graph these absolute value equations and we put them on the XY axis, we see they wind up making these graphs that go boop, boop. All right. So if you have questions over that, drop them in the chat. I'm starting to get the impression that after the early questions that you guys are pretty comfortable with chapter 3 material, which is great. How about word problems with piecewise functions? Anybody need to see those? All right.
Can you go to 29, please? Chat's not working.
Oh, chat's not working. Okay. I wondered why everyone was so quiet. Okay, let me see if I can fix this right quick. Oh, wow, a whole bunch of stuff wasn't working all of a sudden. Okay. Okay, so, okay, now, wow, this is a mess. Hold on. Okay, let me see what else I can do. So my screen has totally grayed out for some reason. Let me see if I can get this functioning at least mildly. Okay. All right. Oh, Emily, I see I missed question 3. Yeah, if you guys could just speak those out. I don't know why this is so messed up.
Yes, I think it was number 3 on piecewise, I think.
3 on piecewise. Okay, awesome. Well, as long as you guys can see it okay, and I know what you guys need, we'll get through this. Okay. So number 3 on piecewise, for each of the functions, find the value of A when we're doing f of -1 and f of 3 if possible. Okay, so f of something just means that you're saying x equals. All right, we're used to seeing f of x, so that just means x equals -1. All right, so on 3, it says y equals x squared minus 1 if x is less than or equal to 0, and x cubed plus 2 if x is greater than 0. So for our first condition, f of -1, we see that when x is less than or equal to 0, okay, so f of -1 satisfies that. So we can say that y is equal to -1 squared minus 1, which will be 1 minus 1 gives us 0. And this is if x is less than or equal to 0. And then our second piece, y equals x cubed plus 2, if x is greater than 0. Well, x is not greater than 0, so we can't do that part. And so what we wind up graphing is all real numbers less than or equal to 0, or in this case, just a single point. Okay, so if f of x, so if x is -1, we get -1, 0. So that would be the solution. And the solution would have this filled in dot because it is less than or equal to. If we had a solution for x is greater than 0, then this one would give us the open circle because we don't include that. All right, so that is f of -1. If we do f of 3, f of 3 gives us y equals x squared. Oops, let me go ahead and just put that in there. Equals 3 squared minus 1, but this is only if x is less than or equal to 0, so we can't do that piece. But we can do the next piece that says y equals x cubed. Let me move that. Y equals x cubed plus 2 because x is greater than 0. So this gives us 3 times 3 times 3 is 27 plus 2. So y is equal to 29. So we have this ordered pair where x equals 3 and y equals 29. And graphing that, and this is just going to be a wild approximation. So say x and y, because this is strictly greater than, x would be 3 and y would be 29, we would have this open circle. All right, does that make sense, Emily?
Yes, thank you.
Okay, wonderful. All right, so let's go back to 29.
Wait, actually, for the first one, in the negative graph or the -1 in the graph, is it an open full circle or is it just an open circle?
The one I wrote in blue,
Yes.
it is a closed circle.
Oh, okay.
Okay. All right, any other questions? Okay, so let's go on to question 29. So immigration in the United States for the years from 2012 and projected to 2060. All right, so personally, I always start writing this out. So 2012 through 2060. I see that the rate of immigration to the United States from Spanish, Caribbean, and Latin American countries per 1,000 and their population can be modeled by this function. All right, so X is the number of years after 2010. That's important because it tells us anytime we see an X, we have to add 2010 to it. All right, so what does this model give us as the rate of immigration per 1,000 population in 2025 and 2035? Okay, so when we have f of x equals 0.011x plus 0.94, and this is if we're between 2 and 20. Okay, this between 2 and 20 business is telling us, okay, plus 2010. So this is telling us if we are between 2012, all right, including 2012. So here, let me put a bracket around that. So including 2012 all the way through. And then if we do 2010 plus 20, that's going to give us through 2030. Come back here. Okay. And so 2012 through 2030, and I'm going to put a parenthesis around that because it does not include 2030. So it says the rate of immigration per 1,000 in 2025 would fit in this model. Okay, so the rate of immigration is going to be this 0.011 per 1,000 plus this 0.94. Okay. Let's see, 29, 64. Hold on just a second. I've got some students that dropped out. Okay, so let me see if I can get more people back in the Zoom from the Zoom waiting room. And I cannot shoot. Okay. All right, hopefully they can jump on tomorrow. All right, so question 29. All right, so if we are looking at this, if we are in 2025, so to answer this question, 2025, we're going to subtract 2010 from that, and that gives us 15. So that tells us we're going to use f of 15 to solve this problem. All right, so we get 0.011 times 15 plus 0.94. So this is part A in 2025. Now in 2035, we see that this part of the function is not valid. And so for 2035, we have to use this piece. And so in 2035, it tells us that f of x is equal to 1.16 if we're 20 less than or equal to x less than or equal to 50. So this is 2010 plus 20. So this is from 2030, including the year 2030, all the way up to the year 2060. If you guys have questions, the chat is not working. You'll just have to speak them out. Please feel free to do so. All right, and so we see that the answer for this one would be, let's see, 2035. If we subtract that 2010, that's going to give us 25. So f of 25, well, we don't have any variables in there because we see that it achieves a constant rate of 1.16. All right. And then the second piece of that would be to graph the function for 2 to 50 and for 2x to 50. We know that that is for the years 2012 through 2060 inclusive. And so we would, as we're doing this, have this piecewise function where we have a solid line or a solid dot for 2012. And then we would come up to 2030 and we would have an open dot. And then down here for 2030, we would have a closed dot. So we would pick up that value and we would have a closed dot all the way through 2060. All right, questions on that one? Okay. Any questions on, let's see, 31? We've got 36 minutes left. If not, that brings us to section 3.5, talking about the quadratic and power models. All right, so do we have any questions on 1 through 6 or question 9? And if you guys didn't do these in class, let me know. You'll have to speak that out because the chat is not functioning at this time.
Can you go over 3, please?
3, absolutely. All right. So question 3. All right, so the equation of a quadratic function. And I grabbed the example from your textbook that used 3 points to do this. All right, so we're going to use the form of the quadratic function. So the general equation, let me highlight this here. There we go. Y equals ax squared plus bx plus c. All right, and what we're going to do is we're going to drop in the values for y and x, and then we're going to wind up with these a, b's, and c's, and we're going to solve using a system of equations. Now, this was my big question when I was putting this together. System of equations is something that doesn't usually show up until, I think it's chapter 7. Have you guys done system of equations yet? Okay. All right, so what we're going to do is we're going to say y equals ax squared plus bx plus c. I'm going to take my first ordered pair, so 6 comma 30, and this is going to give me, we know this is x comma y, so we're going to have 30 is equal to a times 6 squared plus b times 6 plus c. So I can simplify that to 30 equals 36a plus 6b plus, oh my gosh, it doesn't look like it. Here we go, 6b plus c. All right, and then we're going to do this for 0 comma 3, 0 comma negative 3, so xy. So negative 3 for our y is equal to a times 0 squared plus b times 0 plus c. This one is going to bring home the bacon because we're going to get negative 3 equals 0 squared is 0 times a gives us 0. B times 0 gives us 0. And all we have left is c equals negative 3. So that gets us quite a ways down the road. That's very helpful. And then the last one, we have negative 3 comma 7.5. All right. So our y value, xy, y is 7.5, is equal to a times x squared, so negative 3 squared, plus b times negative 3 plus c. Simplifying that expression, we get 7.5 is equal to 9a minus 3b plus c. All right, so the equations we're working with are negative 3 equals c, 30 equals 36a plus 6b plus c, and 7.5 equals 9a minus 3b plus c. And so my inclination is to drop c into both of these and see if we can solve for a and b. And so in doing this, all right, so our next step in the puzzle, I'm going to take this equation and say 30 is equal to 36a plus 6b minus 3. I'm going to add that 3 to both sides. So I get 33 equals 36a plus 6b. All right. And that leaves me really wanting to factor out a 3, but I'm not sure that's going to help us at this point. And then I'm going to work on this one. So I'm going to say 7.5 is 9a minus 3b minus 3. So I'm going to add 3 to both sides and I get 10.5 equals 9a minus 3b. And so, yeah, the thing I would do is I'm seeing here that we've got positive 6b, and negative 3b. And so that makes me really want to take that second equation and multiply it by 2 and then add these together. So when I do that, I'm going to rewrite this. 33 equals 36a plus 6b. Multiplying this equation by 2, I'm going to get 2 times 10.5 gives me 21 equals 2 times 9a gives me 18a. And then 2 times negative 3b gives me negative 6b. So adding those together, I get 33 plus 21 gives me 54. And 36a plus 18a, that sounds like a 54 again, but it's, let's face it, it's getting late in the day. I'm going to double check on my calculator. 54a. And negative 6b plus positive 6b gives us 0 b's. So we see that we can divide both sides by 54 and we get a is equal to 1. So we can plug that a is equal to 1 into the first or the third equation. The third one's got a 7.5. I want whole numbers because whole numbers are big and squishy and easy. So I'm going to say with my a equals 1, I'm going to take my a equals 1 and I'm going to plug it into this equation. So I'm going to say 33 is equal to 36 times a equals 1 plus 6b. And this will allow me to solve for b. And so 33 equals 36. I'm going to subtract 36 from both sides, and that'll give me negative 3 is equal to 6b. Divide both sides by 6, and I see that b is equal to negative 1/2. All right. So very long and involved process, but once you get that, you can turn this into a parabola with those points. Okay, so we've got y equals, all right, going back to our ax squared plus bx plus c, y equals a, or a is 1x squared, plus b is 1/2, negative 1/2. So let me just write that as a negative 1/2. So minus 1/2 x. And then c is negative 3. So that is the equation for my parabola. All right, questions on that one? All right, quite the involved process, but it does give you that general equation for a parabola, and that'll get her done. So there can't be too many of those on the exam, or else that would be the only thing you do, right? Okay, so with 27 minutes left, do we have any, does anybody want to see 23? Solving applications involving quadratic and power models. Okay, so we're still in section 3.3. Remember, the chat's not functioning, so you will have to speak this out. Oh no, we're in section 3.5. Okay. Question 39. Another data table and some functions there. And then question 11, identify quadratic functions given a table of function values. That this is just like what we just did, but with bigger numbers. All right. All right, questions 18 through 22, looking at your textbook. The textbook recommends that you graph this either, excuse me, in your graphing calculator, Excel, Minitab, whatever graphing utility you have available to you. And then you look at the graph and say, okay, whenever I make this scatter plot, does this scatter plot, okay, so let's suppose we have a scatter plot that looks like that. Well, a scatter plot of that kind of data looks vaguely like a parabola, so maybe it's coming up over here as well. And so if we had something like that, we would say, oh, that scatter plot is giving us a quadratic equation. We know it's got some x squared term in there. If our scatter plot of data gave us something vaguely like this, we would say, oh, that's linear. And then I've got some other types in this document that I'll show in just a second. Okay. All right, so any other questions over chapter 3 material before we hit the one section in chapter 4? Okay, fantastic. So chapter 4 does have that algebra toolbox. So if you're having trouble with domain, range, intervals, go back and take a look at that, recalling what a function is. All right, so in chapter 4, you all covered additional equations and inequalities. And so those included solving radical equations and equations with rational powers. Do we have any of those questions that we need to see worked? And if you have questions you'd like to see worked and I skip past them, let me know. I'm still trying to get Zoom to play nice. Not having such luck. Okay. And then next, learning outcomes, solve equations that are in quadratic form. Okay, so the best way to do these is to substitute a different variable for the squared term. So like if we have x to the 4th, say, okay, I think x squared should be equal to u. And so that means that x to the 4th would be u squared. That looks like a quadratic, okay? And we know how to solve quadratic equations where maybe we don't know how to solve a quartic function. Quartic functions have this to the 4th power. All right. Let's see. Exercises 21 through 30, we're solving quadratic inequalities. So if you're comfortable with quadratics, we're just spicing it up with an inequality. So we've got less than, greater than, or less than, and the flip side of those. So if you need any of those worked, please just speak out in the chat which one that would be. All right. Solve power inequalities. So here we have expressions raised to a power where that power is, in this case, greater than 2. All right, so we're taking cube roots and fifth roots and getting this all sorted out. So does anyone need to see 35 through 38? Okay. And then absolute value inequalities. Absolute values, I did grab the snippet from the textbook because we can see what the absolute value paired with an inequality means, because an absolute value means that we do always need to go back and consider, well, do we have a negative root that would work with this? Okay, so we wind up putting that expression in between negative a all the way up to positive a. And then whenever it's strictly greater than, then we have to say, well, you could be less than negative a, or you could be greater than a. All right. So if there are any of these you'd like to see worked, please just speak those out since the chat is not playing nice. And then interactive figure questions basically means we're doing word problems, and these word problems have polynomials. So anything with x squared and up, poly means many, nomial means numbers. All right. And then that gets us through to chapter 6. And chapter 6 looks at higher degree polynomial and rational functions. So chapter 6 does have an algebra toolbox. So go back and make sure that you're comfortable with that information. And if you're not, please seek out some help from one of the learning centers, either the Math Tutoring Center, the Student Support Center, your CEC in your course, or your instructor. Okay, I hate it when people miss questions because they're missing some of these foundational concepts. All right, so these are really foundational. Make sure you've got strong foundation to build your knowledge on. All right. And skipping past that toolbox, we have 3 sections in chapter 6. And this is where we really start to put everything we've learned this semester so far into play. And so we look at how to graph a cubic function. And we had 2 examples from section 6.1. And I pulled the snippet that just describes what is a cubic function. All right, a cubic function is something that's going to have its highest power to the 3rd. And we see that it's going to have one of these turning points if it's just x cubed. If it's got numbers in front of the bx squared, cx, and in the d place, then we see that we're going to have a function that has a couple of turning points. All right. And depending on whether that number out front, if this is positive, we're going to start out down here on the negative and end up on a high note. And if this number is negative, well, now the negative side is going to end on a high note and the positive side is going to end on a low note. All right, so go back and make sure you're looking at these. Quartic functions are going to be those functions that have ax to the 4th. And these can go plus bx cubed plus cx squared plus dx plus e, where a is a non-zero number. And we see that these roughly look like a parabola. Okay, so not to be confused with a parabola, but whenever we just have this x to the 4th, this looks very much like a parabola, but it's kind of flat down here. Okay, so this is not a parabola, but it looks like a parabola. Now, whenever we start adding terms beyond that x to the 4th, we start to see that we get this shape in here. And we see that it will still have open up, or it will still open down, but instead of being smooth at the minimum or the maximum, we're going to have this little bumpy pattern. And sometimes that bumpy pattern is symmetrical. Other times that bumpy pattern is not symmetrical. Okay, so these are our quartic functions. All right. And then I found this little summary table and this description of polynomial graphs that I included in our prep document because it does a great job of talking about, well, what's going on with what we've seen so far. So a linear function is going to have a positive slope, which means it goes up, or a negative slope, which means it goes down as you go from x in the negative region to x in the positive region. It's going to be a degree 1, and that degree 1 refers to the fact that we've got some equation that says y equals x, and that's all there is to it. All right, and the degree, because this is a degree 1, we would say this is an odd degree. Our quadratic is going to be y equals x squared. So it's a degree 2, and our positive leading coefficient will have this opening up with a minimum. Our negative leading coefficient will have this opening down with a maximum and a single turning point. All right. When we get into our cubic functions, we see that we can split these. Okay. And so we've got this positive leading coefficient. So whenever we're in x is in the positive region, and we're dealing with y is equal to x cubed, we're going to end on a positive note. But if we have that negative leading coefficient, The negative x region will be pointing up. All right. And we can see the degrees, we can see odd or even, and then we can see the number of turning points. So when we get down to the number of turning points with the cubic and the quartic is y is equal to x to the fourth. Notice that it can be 2 or 0, 3 or 1. All right. It will be 0 for the cubic function when y equals x cubed. It'll be 2 when we have y equals x cubed plus bx squared plus cx and so on. Same idea with the quartic. Our quartic function is going to very much look like a parabola with just 1 when it's y is equal to x to the fourth. All right. So any questions over identifying the degree, coefficient, and intercepts? Okay. We are, let's see, we got 14 minutes and 11 pages left. Okay. So identify the graphs of higher degree polynomial functions. And so I've got the functions down here, and then I've got their equations up here. Do we have any questions over those? Okay. Oops. All right, please let me know or drop it in the chat if you do have questions, or I'm sorry, you can't drop it in the chat. Please speak out and let me know if you have any questions, and I've gone right past these. All right, I've got lots of emails piling up from students that came out of the session and went back in. Okay, do apologize for that. Technology. Oh. Okay, identify the degree, coefficient, and intercepts of equations of higher degree polynomial functions. Find local minima, maxima, absolute minima, and absolute maxima of polynomial functions. Do we have any questions over 17 through 20 or 33 or 34? Okay. Let me just double check and see what kind of messages I'm getting. Okay, nothing new it looks like. Okay, solve applications involving higher degree polynomial functions. All right, so we've got question 41, question 43, and question 49 as examples. Does anyone want to see any of those worked? All right, and I'm hoping that somebody is still with me. I'm not hearing any questions anymore. Okay. I'm like literally losing more Zoom controls as we go. All right, so section 6.2, modeling with cubic and quartic functions, learning outcomes. Find cubic and quartic models for data and tables. All right, so section 6.2 really comes down to graphing all of the information. And once you graph that information, you can look at the graph, and then based on those values, those graphs I just showed you for linear, quadratic, cubic, and quartic functions, you can decide, okay, does this look like it's modeled best by a cubic function, where our cubic function is y equals x cubed plus bx squared plus cx plus d, or does it look better by the quartic, where I forgot my ax to the fourth plus bx cubed plus cx squared plus dx plus e. Okay, so cubic and quartic. So unlike what we did with the polynomial, trying to find the quadratic equation where we're given 3 sets of numbers, we're not going to do that because A, B, C, D, and E, finding those for the quartic function is too much. We're just going to graph these and then approximate. All right, model and apply data with cubic functions. So sometimes they will straight up say, find a cubic function that models the data. All right. Other times they will say, find the quartic function that is the best model. And so we know we're trying to find something where that highest power is to the 4th. And then sometimes you'll look at these and say, okay, well, I've used this quartic function, but I think it'd be better with a cubic function or a square function. Okay, so we do see some questions like that. All right, so our last section, 6.3, solution of polynomial equations. All right, solve factored polynomial equations. Solve polynomial equations using factoring. Do we have any questions on those? And I'm not hearing anything and the chat is disabled. Okay. Oh my gosh, all that trouble later. Zoom's finally starting to look decent. Okay. Oh, finally. Great. It's looking decent. All right. So let's see, section 6.3. So do we have any questions over 11 through 14? Solve polynomial equations using factoring by grouping. Okay. Do we have any questions over 15 through 18? Solve polynomial equation using the root method. Also questions 19 through 24.
Someone asked for 12.
Okay, thank you. All right, so question 12. All right, so factoring by grouping. With factoring by grouping, all right, we're going to look at these and decide what do we have in common that we could use to pull out. So for 12, I'm looking at x cubed plus 5x squared minus 4x minus 20 equals 0. And so I see here that I could pull out x squared. And I see here I could pull out a -4. -4 is common to both of those. So if I pull out x squared from x cubed plus 5x squared, that leaves me with x plus 5. And then if I pull out -4 from -4x minus 20, this gives me -4 factored out. -4x divided by -4 leaves me with x. And then -20 divided by -4 gives me +5. All right. So from here, we see that x plus 5 is a common term or common to both of these terms. And so we can pull this out and say x plus 5. And once we factor x plus 5 out of both of these, we see that we're left behind with x squared minus 4. And then x squared minus 4 can actually be factored further. That is the difference of two perfect squares. And so we get x plus 5, x plus 2, x minus 2 equals 0. And then we want to solve these. So we would set each of these equal to 0. So we would say x plus 5 equals 0, x plus 2 equals 0. Now my pen's dying. Oh my gosh, technology. And we would wind up solving for x equals -5, -2, and +2. Were there other questions over this section? Remember, the chat's not working. You got to talk to me now. We got about 5 minutes left.
Could
So
you work
actually,
one of the root ones?
the root ones, yes, absolutely. Okay, so one of the root ones, let's grab 16 just for fun. All right, so 16 says 3x cubed minus 81 equals 0. All right, so I'm going to go ahead and move 81 over. So we're going to add 81 to both sides. We get 3x cubed is equal to positive 81. I'm going to divide both sides by 3. So I get x cubed is, let's see, 81 divided by 3, I think is, yep, it's 27. And then we're going to take the cube root of both sides. Okay, and you should have a calculator available to do this. And so on the calculator, you can either, if you get a fancy one, you've got this cube root business, or you can say 27 raised to the 1/3 power. I've got one of these real cheap TI-30X2S calculators. And so I wind up doing caret parenthesis 1 divided by 3. And that gives me 3 for my value. Now, because this is cubic, because it is odd, I know that x is equal to 3 is the only solution. Okay, if I had one like, and not 17, 17's in the book, you can do that. If I had one like 18, okay, where I have 2x to the 4th minus 162 equals 0, 2x to the 4th, I'm going to add 162 to both sides. I'm going to divide both sides by 2. And I get x to the 4th is 81. So if I raise both of these to the 1/4, also known as taking that to the 4th root. Let's see, let me move this. There we go. All right, so because I can say x is equal to, and 81 raised to the 4th root is going to be 3. Because that's an even exponent, I know I could say 3 times 3 times 3 times 3 equals 81, but I could also be slightly amoral and say, oh, -3 times itself 4 times and also get that number. So we would definitely have to say this is equal to plus or minus 3. All right, questions on the root method or factoring by grouping? All right, fantastic. We've got a couple more minutes. Solve and factor polynomial equations using a graph. Any questions on that? All right, getting to the last couple of pages, solving applications involving polynomial equations and factoring. All right, so we've got our infamous profit equation, question 41. We've got the constructing a box equation. So answering interactive figure questions involving the volume of a box. And the solution for that one goes on to the second page. And then we have our revenue. Lots of revenue and profit questions lend themselves well to these polynomial functions. So any questions over those last 3 problems with the minute we have remaining? Okay. I will be bundling both this recording and the notes that I have taken and asking Dr. Cliff to post these to the math tutoring website tomorrow. I will also email the links to you all tonight. So if you participated in the Zoom session at all, Zoom has a record of that, and I will email this to everyone so you have it to look over. Feel free to email me with questions, and don't forget to bug all of your wonderful math people for help if you need it before your exam. Good luck on your final exam, and I hope to see you in 111B and 112B the second 8 weeks. Thank you, everyone.